I just recorded this entire video and the audio wasn't recording. So we're going to do it again. This time, hopefully the audio works. All right. So this is going to be a quick summary of all three pieces of software that you guys are going to need to use for this module's synthetic question. Let's start out here with a piece of software called Marvin Sketch. Marvin Sketch is what we're going to be using to do our Lewis type diagrams. So over here on the right, you can pick your element. You can also pop open a periodic table. We're just going to be using pretty much the ones that are available here. Grab it, click. That easy. You'll notice that it fills in every element you give with necessary protons, hydrogens, so that it becomes a complete molecule and is not just a lone element. So, for example, when we hit C, it gives us methane. If we just click all over the place, we get a bunch of methanes. If we click and hold on the center of one of these molecules and then drag out, we'll get this bond line, and then boom, now we're creating a much more interesting molecule. Of course, we can go around and do whatever weird shape you want. But one thing you should have noticed right away that's a little annoying is that the carbon symbol, the C, disappeared. Now, this is because in organic chemistry, they barely ever bother writing a C. Like, the carbons are so common, they don't care. But for our purposes, when we do Lewis diagrams, we are drawing that C. We have to write that out. So to fix that, you're going to need to right-click where that C would be. You can kind of imagine, right? It's got to be at those corners. And you can see how it becomes a little circle. You right-click and go to Label Editor. Click Label Editor, and this little checkbox down here will pop up that says Alias. Hit that, hit Enter, and bam, you get your C back. Of course, if you wanted to do that to each one, you could just go around and do that. Would not be a big deal. The other thing that we should talk about is we can change which element is at any one of those points at any time. So I can hit nitrogen, come over here, and boom, that's a nitrogen now. Easy. Last thing we should talk about, let's drag this out. So what you'll notice is that I have no lone pairs right now. Now that's just a setting. I can come over here to View, Advanced, Lone Pairs, and bam, my nitrogen lone pairs will pop up. That should be everything you guys need to know about that piece of software. I'm going to close that. I'm not going to save it. Now let's come over to Avogadro. Avogadro is very similar in that kind of point and click interface and the dragging interface. The biggest difference, of course, is that it's three-dimensional instead of two-dimensional. So make sure you have this pencil-shaped tool selected, and then when you click in the environment, you will just drop methane atoms, or methane molecules. Ugh, atoms. Now, like I was saying on the last one, that's not very useful. We're going to want to combine it, and so we just click and drag, and boom. Now, this is actually something that happens all the time. This happens way more in Avogadro than it does in the two-dimensional, where you have that little air. So you're just going to have to undo that. You can do that with Control-Z, and then you can come back and fix up your drag and drop and get it however you need it to be. The one other thing I should mention that I've done a lot is when I have a bunch of these on top of each other, and I'm trying to drag it out, I accidentally click on one of the hydrogens and drag from the hydrogen. It's just a real easy thing to mix up. You can also delete all of them with the right click and just get rid of it. And then if you come over here to this kind of compass, you can be in a navigation mode, which allows you to spin your molecule around. Now, looking at this molecule, you should immediately notice several things. The first is that it looks absolutely ridiculous. Now why? It's because I was really lazy when I was drawing it out and just kind of gave it bond lengths that were absurd, right? So we can fix that with this program. It's got an extension which will do a geometric optimization on the molecule and kind of compute what it's most likely in the ballpark of looking like. It's not a perfect tool, but for our purposes, it'll work. So we come to extensions and we hit optimize geometry. And I think I managed to crash it, which is awesome. So we're going to restart it, discard it. It's probably from all the horsing around with extra methanes I was doing. In general, let's not do that. But let's just draw out the same molecule. Again, kind of similarly long. And go extensions, optimize, bam. That's what should happen. Pretty much instantaneously, you notice it just shrank all of those bond lengths. Let's come back over here to the compass mode. We can spin it around and you can just see, cool, now it looks proper. Let's go back to some of the other things that we could do. Bond order, we can do single, double, or triple. So we can do double, bam, double. We can do triple. I don't think it can deal with it being a triple there. Let's see if we can spin it around and see it. Nah, doesn't want it. Anyway, play around with it. You will switch them around. Also, here in this carbon, this is where you select your molecule elements. So nitrogen, bam, now it's a nitrogen. I should mention, actually, let me show you guys real quick in Marvin's sketch in case you didn't figure it out by yourself, that over here is where I can change the bond order for Marvin's sketch. So it's single bond, but I can change it to double bond, and then again, click on the bond, now it's a double bond. Or triple bond, click, now it's a triple bond. You got very similar to Avogadro. Anyway, one other thing we're going to need to do here, actually let's re-optimize now that I made it weirder. Notice the bond length shrank. Anyway, let's go to Save As. This is how we make an XYZ file. And I'm going to say onto my desktop. Let's just make this weird file. We'll write it out, weird XYZ. Now note, there are lots of file types that it can save out as. If you really want it to be the XYZ type. Hit save, save it out, boom, easy peasy. Next, and finally, let's open up IBAView. Now IBAView is a little weird because it's not installed like the other ones. It's just going to be in a folder that you unzip. And inside that folder, you're going to have to go to this bin directory. When you click this bin directory, you then can go to IBAView. Open that up. And IBAView is really cool because it's got built-in quantum calculations that it can do. Specifically, it'll give us the wave functions for all of the molecular orbitals on a molecule. So let's drag in that weird molecule. Bam. There she blows. With both that's a tongue twister. With both mouse buttons held down, you can drag the molecule around like this, so you can center it. And then with the right mouse button, you can kind of spin it around. Anyway, let's center, and then let's come over here and click Compute, Analyze, Wave Function. This pop-up should be fine by default, shouldn't have to change anything. Just hit OK, and then this will pop up and quickly compute. You'll notice if you want to check that this bottom will say wave function computation finished when it has indeed completed the computation. Then you can just hit close. And now we're going to come down to where it says data sets. Hit that and this will pop up. So a couple things to notice about this. One, these are your lowest energy orbitals and these are your highest energy orbitals. So it's going in that kind of order. Also notice where it says E equals negative some number. I'm not sure if you guys can read that in the video, but you'll be able to read it on your own machines. That's giving you the energy of the molecular orbital, which should give you kind of flashbacks to the worksheets where we were dealing with the hydrogen atom, and we were looking at the different orbital energies for the electron there. So this is a very similar principle, but obviously now we're dealing with molecular orbitals. Now, you'll also notice often that if you click on these really low energy, it didn't do anything, right? Must be broken. Well, what's actually happened is that that orbital is so tiny that it's being rendered inside of the atom. So it doesn't pop up. We don't actually see it easily. But if we click on one of these more high energy orbitals, bam, it's kind of obvious. And immediately what you should be thinking about is, well, what kind of bond are we looking at there? Right? One of the other things that would be valuable to do is compare that bond with that Lewis diagram that we had if we had drawn out this molecule as a Lewis diagram. Is this a single bond or a double bond? Questions like that are really valuable to ask. Anyway, off the top of my head, I don't think you guys will need anything else for this module. If you do, of course, feel free to ask me, email me, talk to me in class. We'll see if we can work it out. Unfortunately, IBAView does not have a Mac version that I'm aware of, but the other one should. But PC would be recommended for this. All right, thank you guys. Have a good one.